the extent of the mathematics. Very few people realize the enormous bulk of the contemporary mathematics. Probably it would be easier to learn all the languages of the world than to master all mathematics at present known. The languages could, I imagine, be learned in a lifetime. Mathematics certainly could not. Wow! Nor is just subject static. Every year new discoveries are published. In 1951, merely to the point, brief summaries of the year's mathematical publications require nearly 900 large pages of print. In January alone, the summaries had to deal with 451 new books and articles. The publications here mentioned dealt with new topics. They were not statements of the existing knowledge, or very few of them were. To keep pace with the growth of the mathematics, one would have to read about 15 papers a day. Most of them packed with technical details and of considerable length. No one dreams of attempting this task. The new discoveries that the mathematicians are making are very varied in type, so varied indeed that has been proposed in this paper to define the mathematics as what mathematicians do. Only such a broad definition, it was felt, would cover all the things that might become embodied in the mathematics. For mathematics today attack many problems not regarded as mathematical in the past, and what they will do in the future there is no saying. Ha 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 ha. Got it. A little more precise would be the definition. Mathematics is a classification of all possible problems and means appropriate to their solutions. This definition is somewhat too wide. It would include such things as the newspapers send your lab problems to Aunt Minnie, which we do not really wish to include. For the purpose of this book, we may say mathematics is the classification and study of all possible patterns. Patterns is here used in the way that not everybody may agree with. It is to be understood in a very wide sense to cover almost any kind of regularity that can be recognized by the mind. Life and certainty, intellectual life, is only possible because there are certain regularities in the world. Compare Poincaré, science and method. A bird recognizes the black and yellow bands of the lap. Man recognizes that the growth of the plant follows the sowing of speed. In each case, a mind is aware of a pattern. Pattern is only relatively stable things in changing the world. Right. Wow. Again, patterns is the only relatively stable thing in changing world. That is why the capturing the pattern is the key for surviving the life, because everything is changing. Everything is in dynamic. Today is never exactly like yesterday. We never see a face twice from exactly the same angle. Recognition is possible, not because experience ever repeated itself, but because in all the flux of the life, certain patterns remain identifiable. Such an enduring pattern is implied when we speak of my bicycle or the river Thames. Notwithstanding the fact that the bicycle is rapidly lasting away and the river perpetually emptying itself into the sea. Any theory of mathematics must account both for the power of mathematics, its numerous application to natural science, and the beauty of the mathematics, the fascination it has for the mind. Our definition seems to do both. All sciences depends on the regularities in nature. The classification of type of regularity of patterns should then be of the practical value, and the mind should find pleasure in such a study. In nature, necessity and desire are always linked. If response to pattern is characteristic alike of the animal and human life, we should expect to find a pleasure associated with the reasonable to patterns as it is with hunger or sex. Wow. It is interesting to know that pure mathematicians, moved only by their sense of the mathematics form, have often arrived at ideas later of utmost importance to scientists. The Greeks studied the ellipses more than a millennium before Kepler used their ideas to predict planetary motions. The mathematical theory needed by the relativity was in the existence 30 to 50 years before Einstein found a physical application for it. Right. Many other examples could be given. On the other hand, many very beautiful theories to which any pure mathematician would concede a place in mathematics for their intrinsic interest arose first of all in connection with physics. Thank you.